Hello, everyone, and thank you for joining us for today's Databricks virtual event, Intelligent Data Engineering Beyond the AI Hype. My name is Matt Jones, Senior Product Marketing Manager at Databricks, and I'm going to be taking you through today's event. So the theme for today is all about making AI-powered data engineering practical. And if you are a data engineer, or if you manage a team of data engineers, or work with data engineers, or just want to learn more about some data engineering best practices, this is the event for you, and we are thrilled to have you here. So I'm going to start off by asking, I'm curious how many people here are familiar with the Gartner hype cycle. And if you're not, in short, there's this framework that suggests every new technology more or less adheres to this curve of expectations over time. So first, there's a new innovation trigger, which results in a surge of hype around that new technology as everyone races to either take advantage or be left behind. However, organizations soon realize that this new tech in a vacuum isn't a magic cure-all. This results in cynicism and disillusionment around the new technology. And in most cases, over time bears out that the real value is somewhere between that peak of inflated expectations and the trough of disillusionment as the tech evolves and is applied in more intelligent ways. Does this sound familiar? And if you'll forgive me for leading the witness, it should sound painfully familiar because we've been riding this roller coaster around generative AI for the better part of the last couple of years. So you can see from Gartner's latest hype cycle for generative AI, how they've broken out a number of Gen AI workloads, many of them hovering at that kind of precipice of this peak of inflated expectations. And at Databricks, we see this all the time. So nearly 100% of customers we talk to have been working to figure out how to translate the potential of Gen AI into real business value on top of their existing classic AI projects. But according to a Forbes article published this September on Gen AI hype, only 20% of AI projects today are successful in the real world. And this gap between expectations and reality creates tremendous pressure on the data teams tasked with building AI applications, but also feeding them with quality data and using AI to accelerate their own productivity. So the last two of these, delivering quality data and using AI to boost productivity, are directly applicable to the discipline of data engineering. So today we're going to zero in on those and talk about how real-world data intelligence unlocks this value in the world of data engineering. So just a brief look at the agenda so you know what's ahead of you today. Michael Armbrust, Databricks Distinguished Engineer, is going to kick us off by talking about the vision for Databricks Lakeflow and how we're building data intelligence into the platform. Then you're going to get a really cool demo of Databricks Assistant with Weston Hutchins. We're going to talk about Lakeflow Connect for native ingestion connectors. And then you're absolutely going to want to stick around to the end because Frank is going to give an incredible end-to-end demo that walks through all of this in a production environment. And then, we're going to stop talking. We're going to turn things over to a couple of our customers and let them tell you for themselves how data intelligence with Databricks has really revolutionized their data engineering workflows. So with that, I'm going to kick it over to Michael to lead us off.
Thanks, Matt. I'm really excited to be here today to talk about the intelligent unified data engineering platform that we've built at Databricks. So for a long time, we've been talking about the data lakehouse, which is an open, unified foundation for all of your data. But today we're going to talk about how we can add in the power of generative AI and easily scale and use your data to do custom AI. And together, this creates what we've been calling the data intelligence platform. It democratizes data and AI across your entire organization. But before we get into that, I want to talk about some of the challenges that people run into today when they don't have a platform like this. So getting data is almost never a problem. Today, there's more data at your disposal than ever. But where people struggle is actually unlocking the potential of that data. So talking to our customers, we've seen the majority of organizations are fully dependent on data engineers for every aspect of data pipeline creation and management. And almost all of these organizations require data engineers to be involved in some aspect of creating and maintaining data pipelines. but getting access to those data engineers can actually be pretty difficult. So there's typically 3 steps to starting with data and getting to that kind of final productionalization where you get value from it. But oftentimes, these data engineers have to cobble together many different sources and tools in order to accomplish this. So every data problem starts with ingestion. And this is, getting the raw data into the system. And so you might use Spark, you might have data in Salesforce or MySQL. You might need to get a tool like Debezium to pull the change feed out of MySQL. You might need to get a tool like Airbyte to pull the Salesforce data out into Delta. And then you can kind of cobble it together with Spark. Once we've got the data in, then we need to transform it. So you might use something like dbt. You might need to learn about incremental models so that the performance is good enough. You might even try a tool like Delta Live Tables. And the job that you're typically doing here is filtering, augmenting, and aggregating that data so that it's ready for consumption. And then finally, once we get all of those different pipeline tools working together, we need to orchestrate it. We need to get it ready for production. We need to make it run regularly while balancing cost and latency. And here there's a bunch of different options. You might use something like Apache Airflow or Oozie for doing the orchestration. Of course, we're going to want to monitor these pipelines to understand what's working, what's failing, what's falling outside of SLAs. For this, you might use tools like Datadog or Amazon's CloudWatch. But as you can see, all these tools together start to become a pretty complicated system to manage. And that's why I'm really excited today to talk about Databricks Lakeflow, one data engineering solution that is powered by data intelligence that walks you through all of these 3 steps required to do data engineering: ingest, transform, and orchestrate. So the key idea here is this is an intelligent engineering solution that's built specifically for the lakehouse. So it's one single unified data stack that you don't need to piecemeal manage a whole bunch of different tools. Ingestion, transformation, and orchestration are all available in a single place. A key idea here is we want to empower those data teams so that you don't have to go to a data engineer for every single data problem. We've designed the system to be usable by a broad set of users so that we don't need to restrict those who need more power. And we allow you to create simple pipelines that do both ingestion and transformation with only a few clicks in the UI. And just because it's simple doesn't mean that we can't handle more advanced use cases like sub-second streaming. You still have access to the full power of Spark for the users that need it. And we want this to be reliable and ready just in time. So we have fully managed ingestion connectors that run on our reliable serverless architecture. We have built-in data quality and lineage, so you can track exactly where the data is coming from and where it's going. And we can automatically optimize either for low cost or low latency just with a click of a button so that you're spending money where you want to be spending it and getting data at the times that you need it. So starting off at the beginning, I want to talk about Lakeflow Connect. These are simple ingestion connectors for a wide variety of sources, everything from databases to enterprise applications. So if you've got data in MySQL, Workday, Salesforce, Postgres, all you need to do is click in the UI and we can ingest that data into the lakehouse. It does efficient incremental ingestion, so you don't need to worry about how to make this as cost-effective as possible. And it's powered by this company that we acquired about a year ago called Archeon, which is how we get those change feeds out of these different databases. Once you've got the data in, the next step is transformation. And this is done by Lakeflow pipelines. Lakeflow pipelines give us declarative data flows from simple transformations to real-time processing. The key idea here is you're doing these declarative data transformations in SQL and Python. Declarative means that rather than telling the system exactly how those transformations should be done, you just say what data should exist in your lakehouse, and we figure out the most optimal way to run it. In a few slides, I'll talk exactly about why this is so important. And a key idea of Lakeflow pipelines is highly scalable, automatically incremental processing. So we're not recomputing your entire data set every time. We're taking only the new changes and propagating them through your entire lakehouse. And the way we do this is by unifying the batch and streaming APIs of Spark SQL into kind of one single easy-to-use system. So you might say, well, wait, why is it so important this is declarative? I know how to write Spark programs. Why is it important to make this simpler? And for that, I want to do a case study where I actually walk through a super common use case called change data capture, where basically we're getting a change feed from some source system. It could be Kafka, it could be Kinesis, it could be files that are uploaded to S3. And the very common pattern here is there's some primary key. You get this kind of ever-growing table or ever-growing stream of changes to it. There's a timestamp that says when the change happens, and then there's a bunch of columns that have the actual data. And the problem that we're trying to accomplish here is we want to take that feed of changes and materialize it into an up-to-date table that has the latest value for every key by that timestamp column. So you might, if you're familiar with this problem, this is often called SCD1 or slowly changing dimensions type 1, where each time you see a change for a given record, you're just going to update it in place. Let's walk through what it would take to build a procedural program that accomplishes this goal. So if you Google, you'll probably find a bunch of examples of doing this with structured streaming and for each batch. So we're just going to take that streaming data frame that has this set of changes. We're going to write this upsert into Delta function that will take each micro batch and it will call the merge into command. And so just walking through this code here, you can see we're reading this feed. We are basically writing it into this table called CDC data. And we're going to find the records by this primary key. And then whenever we find a matching record in the destination table, we'll update all of the columns. And anytime we find a new record, we'll just insert it. So this is kind of commonly referred to as an upsert. And so this looks pretty simple. It's only 14 lines of code. What's the problem with this? Well, the first problem is oftentimes you might get multiple updates to the same key in the same microbatch. So you can see in this case, we've got 2 updates to the record with the key ID 1. And we're not sure which one should win. We need to actually pick that latest one, the one where the timestamp was updated at time 3. So this is actually just going to throw an exception. The code won't work. We'll have to go in and change it. And the way we're going to fix it is we're going to do an aggregation. We're going to take that micro batch. We're going to find the latest value for each key using this maxmi aggregation. And then we'll explode back out that latest value so that we will only have one update to each key in each micro batch. So I'm going to go ahead and modify the code. Now we've got 18 lines of code, a little bit more complicated, but not too bad. So is this going to work? Well, unfortunately, there's another problem. It turns out that these multiple updates can actually arrive out of order, even across microbatch boundaries. So if this, record for, updating key number 1 arrives out of order, we'll actually kind of allow the records to go back in time, and which is not what you want. You want the latest value, not some kind of arbitrary value based on when the data arrived. So we'll have to make this a little bit more complicated. What we're going to do is we're basically going to store a version in each row to remember the timestamp when that row was last updated. And now we're going to modify the merge command to actually check and say, is this value that's coming in later than the one that's already stored? If so, go ahead and update it. Otherwise, keep the current value. If this is an earlier record, we can just drop it. So we'll modify our code again. Now it's getting a little bit longer, 22 plus lines of code. And it's really annoying to do this for kind of super long, wide tables with lots of columns, but not too bad. We've got it modified. So does this work? Well, unfortunately, there's another problem with it. We need to handle deletes. So a pretty common pattern is you will, when you want to delete a record in one of these change feeds, you'll just have a special column that indicates whether or not this is a delete record or not. So we'll add this is deleted column. We'll go ahead and modify the code to have this when matched and that flag is set, delete that row. Now we're up to 23 lines of code. Is it working? No. Unfortunately, there's still one more problem. And this is when an update arrives late after a delete. So the problem here is these records have been reordered as they were coming into our system. We already deleted this record and the timestamp to remember, that this delete happened later in time. And we get this update, and what that's going to cause is basically what we call a zombie row. This row is going to be reborn, even though it was supposed to be deleted, and there will never be an update to it again. So it's just going to sit there forever in this kind of undead state. And so this is obviously going to really confuse my downstream users. We'll need to fix it. Unfortunately, the solution is a little bit more complicated. Instead of deleting a row, we're going to have to change it to be soft deleting them. So we actually keep kind of what we call a tombstone that remembers that this row was deleted at a certain time. We'll have to redirect all of my downstream users to query from a view instead that filters out these tombstones because they don't want to see these deleted records. And then we're going to have to build some cleanup process that removes these tombstones after some period of time where we're no longer worried about late data arriving anymore. So going back to our code example, we had to add a couple more lines here. We had to build this extra view and redirect all of our readers to query from it. We have to build this separate job that is going to run cleanup periodically. So now we have over 24 lines of code, one view, and one cleanup job to manage, this seemingly simple problem has gotten pretty complicated. And this is where declarative programming can be super powerful. When we have these common patterns, we can distill them into simple instructions for you to give the system. So let's take a look at this easier way of accomplishing things. Declarative CDC using apply changes into inside of a Delta Live Tables pipeline. So here, all we're going to do is we're going to say, take these changes, apply them to this data. We're going to give it a stream of changes coming from the source system. We'll tell it the primary key is this column called ID. We'll tell it the timestamp column tells us how these rows should be ordered. And we'll say, which column holds that deleted flag. 5 lines of code automatically handles all of the race conditions we were talking about before. And this is where declarative programming gets so powerful. We don't have to talk about the race conditions. We only have to talk about our goal, and the system is in charge of figuring out how to execute it. And it actually gets even more powerful than that. A pretty common pattern is you might have, rather than getting a change feed that has all of the columns in it, some systems will only tell you the columns that have changed. Well, unfortunately, that would make the code even more complicated. Instead of keeping a single version, you have to keep a vector clock that keeps a version for every single column of when it was updated. But in declarative programming, it's actually still simple. There's just this one extra clause. And then another concept that you might need to implement is SCD2. This slowly changing dimensions type 2 rather than updating in place will keep a history. I'd love to talk about how you would implement that by hand, but actually it's too complicated to cover in a short keynote. But with declarative programming, all it takes is this one extra line of code. So that works for these simple cases where I want to do kind of a very standard thing like change data capture. But what about more complicated pipelines? Well, one of the coolest things we've released in the last year is materialized views in serverless pipelines. And basically what this means is instead of writing complicated Spark programs, all you need to do is write a SQL query, and we will automatically figure out how to incrementalize that SQL query as the input data changes. So you can see in this example, we're doing a join on this primary key ID. And this code, while seemingly simple, is automatically going to handle schema evolution. It's always automatically going to handle failures and retries. And it's automatically going to choose between several different strategies of what is the most efficient way to update the contents of this table, depending on how big the input is, whether there's deletes in it or not, whether there's any constraints that allow us to do kind of self-maintainable materialized views. And so this deceptively simple code is actually doing quite a bit of stuff automatically. For other use cases, you might really care about latency, and this is where we're particularly excited about real-time mode for streaming. This allows you to take those structured streaming jobs that were taking, seconds to minutes and bring down the latency into the milliseconds. And so you can see here's a bunch of benchmarks that we did of different types of streaming queries, everything from like stateless stream static joins to stateful aggregation to stream joins. And you can see kind of across the board, this gives us dramatically lower latency just by activating this mode of structured streaming, still using the same API as you know and love. So now that we've talked about pipelines, I want to move on to orchestration. And orchestration in the Databricks platform is done by Lakeflow jobs. This allows you to orchestrate any production workload. It's built on this kind of high reliability core. And the coolest part is it gives you full observability and monitoring. And this contains a whole bunch of different innovations that we've released in the last year. Everything from file arrival triggers, which I'll talk about in a few slides. It works on top of serverless compute. And we've just continued to make this orchestrator better and better. So it can update dashboards. It can run machine learning models. It can update materialized views and streaming tables. You can even express complicated constructs like for each, where rather than a job being just a static DAG, it actually takes as input a whole set of values, and then it will execute the same task on each of those individual values in parallel, managing all of that for you. So pretty cool stuff, and definitely the right way to do any type of production on the Databricks platform. Let's dive into a couple of the newest features. A key thing that we've released recently is file and table triggers. These give you just-in-time execution that optimizes for both cost and latency. Before we had triggers, there were a couple of options. You could create multi-task DAGs or directed acyclic graphs, And these are a powerful tool when you own the entire flow, when you want to ingest and then transform and then build a machine learning model. Expressing that as a DAG is a really powerful abstraction. But this breaks down for organizations where there are thousands of downstream consumers. You don't want that DAG to be kind of a central point of orchestration where everybody needs to get their job into it in order for them to kind of automatically run once the upstream data has changed. So what people have done in the past is they've just done it with schedules. But now you're playing this guessing game where you have to kind of figure out exactly how long is the upstream data going to take to process. And if you get it wrong, you're either going to be missing the latest data or you'll have kind of latency that is much longer than it needs to be. And so this has always been a kind of painful and error-prone process. And that's why we're extremely excited about triggers, because these give you the best of both worlds. It's decoupled orchestration, where you can kind of depend on data upstream from you without needing to bother those users that are producing the data, but it updates only when data is needed as soon as that data is ready. So definitely check this out. I think it's one of the coolest new things that we've added to the orchestrator. The other really nice thing about Lakeflow Jobs is it provides a single unified monitoring surface to look at all of the operations across your entire platform, both to understand if there's failures that need to be addressed, if you're missing your SLAs anywhere, but also where the money's going and whether or not you're getting the most value for the money you're spending on your data platform. And as you can see here, it works for everything from ingestion to streaming tables to materialized views to notebooks, kind of all in this one-stop shop for understanding your operations. And this entire Lakeflow orchestrator is built on top of many of our advanced capabilities. So we have Unity Catalog, which provides lineage and governance across all of the data stored inside of the Lakehouse. We have serverless compute, which auto scales and gives you exactly the right resources for every job without a lot of manual tuning. And then we, of course, have the data intelligence platform, which uses AI to help improve all of your programmers so that they can use the platform to its best extent. Now, you might say, I'm already a Databricks customer. Is this going to be a big painful migration? How do I move to Lakeflow? Well, a key tenet here, as we've been building this is an evolution of the systems you've already come to know and love. It's 100% backwards compatible with Delta Live tables and workflows. Live tables are becoming Lakeflow pipelines. Workflows are becoming Lakeflow jobs. And if you're really excited to try this out, I want to talk a little bit about the schedules. So in terms of ingestion, Lakeflow Connect is already in public preview for several different data sources. You can talk to your account team to try it out. Lakeflow pipelines and jobs and that new unified experience is coming soon. Now, of course, all of this is built on top of the open foundation and can integrate with all of the different services kind of inside of the Databricks ecosystem. And on that note, I'd like to call out one particular part of the ecosystem that I think is particularly powerful. And with that, I'll send it back to Matt. Thank you very much.
Thank you, Michael. I think the Lakeflow vision is incredibly exciting, and there's a ton of work going on behind the scenes right now, building this incredible unified experience. So while the codified data engineering best practices that Michael talked about reflect one aspect of data intelligence, another aspect is just as impressive, and it's right there in the product for you to use today. I think this upcoming session by Weston Hutchins is really going to blow you away if you're not super familiar with the ins and outs of Databricks Assistant. So with that and no further ado, I'm very happy to turn things over to Weston.
Thanks, Matt. I'm excited to be here. My name is Weston Hutchins. I am a product manager that works on the authoring experiences here at Databricks. And one of the products that I get to work on is the Databricks Assistant. So this session today is all about engineering with data intelligence. And when we talk to a number of customers, one of the biggest things that we hear from them is that they really want to empower their data practitioners to use natural language to get jobs done faster. But they run into a bunch of problems. First off, these AI assistants, they don't really work that well on enterprise data. First off, like Gen AI is really a search problem. And these Gen AI tools have a lot of trouble locating the right data sets. Additionally, it doesn't always know the context of how your data works for your organization. It's really only trained on generic responses. So oftentimes you need to inject a lot of company-specific jargon or knowledge in order to produce accurate responses out of these assistants. And then lastly, they don't always comply with access policies. A lot of customers really want to make sure that we lock down our AI assistants to only have access to data that the user has access to. And that's really why we built the data intelligence platform, powered by our data intelligence engine. This is a compound AI system full of models, vector indices, and other AI components that take into account all of the metadata that's stored in Unity Catalog, including things like recent files you've accessed, popular dashboards across your company, maybe recent notebooks and queries that you use. And we use this to tailor answers out of these Gen AI tools so that we can always locate the right data assets, we can generate highly relevant responses, and it's all locked down and governed by Unity Catalog. So you have a central governance layer that only shows responses and data that you have access to. And the primary way that users interface with our data intelligence engine is through the Databricks Assistant. This is our context-aware AI assistant that generates, explains, and fixes code using natural language. It's available in the SQL editor, the notebook, and we're also bringing it to all parts of Databricks. So you can ask it questions whether you're on a jobs page or in the Catalog Explorer. And this really leverages, your metadata. So Unity Catalog metadata, code cells, libraries, other types of information really power the responses that that the AI assistant can generate. And we have found that, one of the biggest things that it helps with is just debugging errors. If you mistype code or you don't have access to something, the assistant can help with those resolutions. And customers, we've been really overwhelmed with the feedback here. So I love this quote from Corning Incorporated. They really started to embrace the assistant as part of their daily driver to really help them get jobs done inside Databricks. And they're not alone. Like we've been hearing from customers all over that once you start to use the assistant, it's really hard to go back. It's kind of tough to take it away from them. And so we're really just thrilled about the response we've been having with our AI assistant and can't wait to continue to add more improvements and improve the quality over time. And so the last thing is, before I get to the demo, is, we're really thinking about this, the assistant for different personas. So we have a number of different data practitioners that work inside Databricks, data scientists, engineers, SQL analysts. Those are primarily going to be using our assistant in Databricks, but we're also thinking about business users inside your company, maybe non-tech users that just want to get access to a dashboard or ask a question about a chart or visualization. And for that, we've built AI dashboards in AI Genie. That's going to be our product that really helps to leverage AI to provide instant insights. Now with that, we'll jump over to a demo. Okay, so here I am inside Databricks on a Catalog Explorer page. And what you see here is a table that I've ingested. It's the top 1,000 movies on IMDb. And one of the first things you do when you ingest data is you want to add high quality metadata to all of the columns. We've added this handy AI assistant feature here to generate strings and suggested strings for each column that you have in here. And that's just really helpful in adorning all of your tables with high quality metadata that can then be leveraged by systems such as search. So if I go up here, I can say things like, where can I find my movies table? And it leverages that information that I just put in here. You can see that that it's returned the table that I was looking for, and I've used this frequently inside my organization. But oftentimes you want to do this in the context of a data exploration. So to do that, let's go ahead and open up a notebook. I'll connect to a compute cluster, and we'll open up the side panel here. And some of the things you can see here is that I can click on some of these buttons and say, where is my movies table? And this allows me to search for tables and objects without ever having to leave my notebook surface. You can see that it calls the same semantic search API. I'm able to use natural language in addition to sort of keyword search. And if I select the query in natural language, this allows me to sort of prime my assistant with cells that I can then ask more detailed questions and code generations examples. Now, what's really nice about this is the assistant is itself a notebook, which allows me to do things like execute code in here and manipulate data using filters. I can either do that or I can copy it into my notebook here. But what you'll find out is that the assistant tends to operate like a very handy scratch pad. So you can use it to iterate over complex things, maybe like regular expressions that require a lot of iteration. So great. So I have my table in here. Once it's been, once the assistant knows what tables to operate on, you can start asking questions and it'll generate the appropriate SQL or Python transformation code. So I can say things like, what are the top genres in this table? And it will leverage our data intelligence engine. It'll leverage like recent queries that I've run and spit out some text to SQL for us so that we can actually see that drama is by far the most popular category in the IMDb Top 1000. But it can actually do things that are a little bit trickier, like parsing, which is a very common thing that you need to do when you're trying to prep or clean data. So I can say things like, what are the longest movies by runtime? Runtime is a column that looks and you can see here that it actually gets the casting information correct for me. I can go ahead and accept it and run this. And what it's actually done is taken my runtime column, casted this out from a string to an integer, and then using that as my sort value across this table, which allows you to really easily manipulate data inside Databricks. We've also started to add other features more than just using these side panels or these inline assistants here. You can come in here and use our assistant autocomplete. So I can say, write a query to find the top 10 movies with in the drama genre, a rating greater than 8.0. And you'll see that the assistant starts to select and autocomplete things without me having to type anything. And so this is just really, really handy for completing columns, generating Python transformations. It takes into account the variables and the data frames that you have and brings that forward with our autocomplete in order to provide just a very seamless, editing experience in the product. Now, we've done more than just code generation and SQL generation. We've actually used it to, help you get other jobs done in your product, such as cleaning up your notebook before you want to share this out. So you can start to say things like, rename the notebook, or you can come in here and you can even use some of these other / commands to add comments and documentation so that this is ready to be checked into to get. And just to wrap up, I'll go ahead and I'll rename my entire notebook here. Now this is ready to go. I can check this into my code repository and then share this out with my organization. So that's the end of the demo. Thank you all for watching. If you want to go and learn more about the Databricks Assistant, you can go to databricks.com/product/Databricks Assistant. On this page, you can find demos and tutorials for getting started with our Databricks Assistant. Customers are loving it. I hope that you'll love it as well. Thank you, Matt. I'll hand this back off to you.
Thank you, Weston. The things that you can do with Databricks Assistant powered by real intelligence in your unique organizational data and context is really astounding. That said, a lot of the time, the data engineers that we talk to are spending more of their time on less exciting, more painful, tedious work like configuring and fixing data source connections. So to talk about how we're fixing that problem, I'm thrilled to turn things over to Elise Joris.
Hi, everyone. My name is Elise, and I'm on the product team here at Databricks, and I'm here to talk about Lakeflow Connect, which is our new suite of ingestion connectors that anyone can use to build incremental data pipelines at scale. At the start of this event, Michael shared an overview of Lakeflow, which is a new solution spanning ingestion, transformation, and orchestration. With Lakeflow, the future of data engineering is unified and intelligent, from authoring to monitoring and everything in between. Lakeflow Connect is the first of the 3 components to launch, and it's our focus for this segment. Specifically, we're going to cover the current landscape and our ingestion offerings. Then we'll explain how Lakeflow Connect fits into that and what features we're going to offer. We'll also touch on the Databricks partner ecosystem and how our partners are critical to our success. And finally, we'll do a quick demo of the product before we dive a little bit deeper into what's powering that demo under the hood. Let's start with why we care so much about this topic. It's pretty simple. Before you can take advantage of Databricks, you have to access your data, and that data is probably all over the place. You have it in SaaS applications like Salesforce, Workday, ServiceNow, GA4, NetSuite. You have databases like SQL Server, Postgres, MySQL, Oracle. You have file sources, message buses, APIs, and so on. But it can be really difficult to get that data into your lakehouse so that you can do meaningful things with it. To start, SaaS APIs can be difficult to ramp up on. They also change a lot, so it's hard to keep up with them. Database pipelines are arguably even harder to configure and manage, especially without impacting the source. So you have to do a lot of work to build these pipelines, to optimize them, and particularly to maintain them. And spending time on all that can get super expensive, plus it slows your time to value. It doesn't help that these pipelines often require a specialized data engineer, especially when those people are super high demand and have a bunch of work piling up. So the people who need to use this data, the HR analyst, the financial planner, maybe the product manager, they're all blocked. It's really the opposite of democratization. And you might not even want to democratize your data when you have a patchwork of pipelines because it's so hard to govern it effectively. Things like access control, lineage, observability. So at the end of the day, you're not fully utilizing your data, you're probably running into pipeline outages, and you might even have some security risks. Now, Databricks has already done a lot of work to address this, and we're going to cover some of those existing solutions so that we can help contextualize where the new offering sits in our portfolio. First, there was structured streaming, which is an API for incremental stream processing in near real time. Engineers love the performance, the scalability, the fault tolerance, but over time, they asked for more automation and less overhead. They wanted better auto-scaling, data quality constraints, failure recovery, and so on. So we added Delta Live tables. DLT is a declarative framework for building reliable and scalable data pipelines. You define the transformations to perform on your data, and DLT manages orchestration, monitoring, data quality, errors. And customers love that it reduced the complexity that we've been talking about while also improving the performance of their pipelines. But what's next? Well, these days we're hearing a lot of demand for something that is even easier to set up, even more hands-off, especially when dealing with complex data sources. You don't want to spend time learning about those SaaS APIs and all of their edge cases. You don't want to deal with the networking complexity of on-prem databases. You don't want to get paged in the middle of the night because you maxed out your API limits and now your data pipeline went down. That's why we're introducing Lakeflow Connect. These are simple ingestion connectors that any practitioner can use to build incremental data pipelines at scale. It includes native ingestion connectors for top SaaS applications, databases, and file sources. And to really explain this product, I want to talk about the three things that we are most excited about. The first is simplicity and ease of use. The second is unification with your existing tools, your governance. And the third is efficiency. To start, the connectors are easy to set up, which you're going to see when we demo in just a couple of minutes. And once you've set a connector up, it's also fully managed. Insofar as we have the ability to solve a problem, Databricks holds the pager when something goes wrong. This lowers your maintenance costs, but more generally, it means you get to spend less time moving your data and more time getting value from that data. Practically, we're providing things like automated schema evolution, robust observability, robust alerting, automated retries and error handling, automated connector upgrades when third-party APIs change, SCD type 2. And I could keep going. This list of features gets quite long, and it'll only get longer over time. We're also planning for schema mapping, time travel, change data feeds, data sampling, even more robust schema evolution. It's a really iterative roadmap. Plus, we wrap this all up into a simple UI and a simple API. Now, I think that's pretty awesome in its own right, but you might be thinking to yourself, well, every provider wants to offer easy, low maintenance ingestion. That's almost table stakes, which is why we need more. Specifically, we're also focusing on unification with the rest of your Databricks tooling. This product is governed via Unity catalog. It's orchestrated with jobs, which means it's going to integrate with Lakeflow jobs and so on. So you don't need to learn another platform, and you can do ingestion in the same place where you do orchestration and analytics, ML. For example, you might want to track the lineage of your ingested data. That's coming with the Unity catalog integrations. Or you might want to add a notebook that flags PII after your data lands. Well, you can tack it on with a table trigger in workflows. You might want to avoid having your data travel across accounts, maybe even clouds. And because we keep everything in your account, we have less data transfers, so you get more computational efficiency. Altogether, the goal is to help you take advantage of all the reasons you chose a lakehouse in the first place and to really seamlessly plug into your existing workflows. But what might be truly special is how we handle incrementalization. We're pretty efficient at reading and writing and even transforming your data, which directly impacts the cost and the performance of your ETL. For starters, we incrementally read the data. We're generally not reading everything and applying a diff. Where possible, we only read what's changed. And we should mention that there's no blanket approach to this. We're often optimizing the approach for each source and sometimes for each table. That improves the performance and the reliability of your pipelines while also reducing the risk of bottlenecks and any impact to the source system. But incrementalization doesn't stop at reading the data. We can also generally write the data that's actually changed. So you'll be able to use change data feeds to capture a history of those changes. But we still don't stop there because ingestion is really just step one. We can actually take advantage of products downstream that incrementally process the data as it works its way through the medallion architecture. For example, if you want to construct a materialized view to do downstream transformations, features like Enzyme can process updates to your view incrementally as that data continues to stream in. And our customers are seeing nice performance in practice. For example, when Katahi Logistics tried our Salesforce connector, they reduced their total ETL latency by up to 6x. Now, even with all of that, we are just getting started, both in terms of the connectors that we offer and the features that we provide in each connector. I should note that this roadmap may shift as we go, especially as we get feedback from you all, but we are already in gated public preview with connectors for Salesforce, Workday, and SQL Server, and we're also in private preview with connectors for ServiceNow, Google Analytics, SharePoint, and NetSuite. I'm particularly excited about our SharePoint connector because it represents our first foray into unstructured data ingestion. If you're interested in trying any of these connectors or learning about their current limitations or influencing the long-term roadmap, please do reach out to your Databricks account team. Now, we keep saying that ingestion is really just step one, and it's not just about getting the data into Databricks. It's about using that to solve your organization's most challenging data problems. So I want to briefly touch on just a few of the most common use cases that we're seeing for these connectors. For example, a lot of organizations have a customer 360 use case. This is about creating an end-to-end solution to transform and secure and analyze your customer data and potentially predict future behavior. We also hear a lot about centralized human resources, staffing, time tracking, compensation, benefits, all on a centralized data platform. Or you might have a lot of files coming from IoT sensors, and you need to deliver that to your downstream applications, and so on, like portfolio management, consumer analytics, chatbots. The list of use cases goes on and on. Now, I've also talked a lot about native connectors, but you might be wondering, what's the relationship with all of our ingestion partners? It's simple. Our ingestion partners remain vital. They offer a really wide range of connectors, and those connectors have deep functionality that's maintained by dedicated teams of experienced engineers. And we want you to continue having that choice So we will continue to work with those partners to offer as many high-quality connectors as possible. Even when there is a native connector for a given source, we're going to continue to support that optionality. We'll continue to highlight them in Partner Connect and so on. We're just now adding the critical connectors that customers have requested of us, because ultimately we want to make you successful. It's your data, it's your choice, and you can absolutely keep the tools that you know and love. But I think that's enough background. Let's actually see this in action and then talk a little bit about what's going on under the hood. I'll start off by setting the scene for this quick demo. Let's suppose that I am a data engineer for a car company called Speedy Motors, and my organization has data across a variety of sources, Salesforce, SQL Server, and so on. And I want to pull them in so that downstream users can create dynamic AI BI dashboards. Before Lakeflow Connect, I probably would have ingested this data with a combination of different tools. For example, I might have extraction software that's running on a virtual machine, which means I need to think about what kind of infrastructure to allocate, what scale I'm going to need, how I'm going to keep that software up to date. From there, I might create a message bus that subscribes to all of the events that are generated from my source, and then maybe I'd write some custom code to capture those events in a notebook that uses structured streaming to get my data into the lakehouse. This solution works, but it is going to take me a long time to set up. And I also need to worry about ongoing maintenance, right? If there's a change to one of the source APIs, it's possible that things could entirely break. Now with Lakeflow Connect, I can ingest my data into the lakehouse without that complexity. All I have to focus on is what data I need to ingest. So let's see this in action. To get started, I'm going to visit the Add Data page. Here, I'm going to see all the sources that are available for me to ingest. And for this demo, I'm going to show the user journey of getting data out of Salesforce. So I'm going to click into that Salesforce tile. From here, I'm brought into the pipeline setup wizard, which has just a couple of steps to begin ingesting data. It's important to note that all these steps can be completed within the UI. But if I prefer coding instead of clicking, there is also an API that does the exact same thing. It's partially integrated with Databricks asset bundles, and we do plan to support Terraform. Now, to create this pipeline, I'm going to provide a name for it. I'll call it Salesforce Ingest Pipeline. And then I have to connect to my source. Now, here I already have a UC connection that stores my Salesforce credentials, so I'll select that. If I didn't already have this, I could quickly create one and authenticate to Salesforce using OAuth. Either way, we keep these credentials secure using built-in UC permissions. I need the explicit ability to use this connection in order to ingest data with it. From here, I am ready to create my pipeline. Now, once my pipeline has finished initializing, I'm going to be able to move on and begin selecting my Salesforce tables. I should note that this has actually evolved since we filmed this. Validation now happens in smaller chunks following each major action that you take in the wizard, and we're going to continue to make improvements like that. Now here, I'm able to browse all the tables that are available to my user in Salesforce, and I can choose to either ingest all the tables or only specific tables. Column level selection is also in development. So for this use case, I need the account, product, and opportunity objects. So I'm going to search for those and select them. As a side note, it's possible that the schemas of these tables could evolve. For now, we support the addition of new columns, but we do plan to expand schema evolution to support more advanced use cases. Next, it's time to decide where my data goes. I already have a catalog and a schema that I want to add to, so I can search for it. Alternatively, I could create a new destination right here on this screen. And going forward, as with many parts of this wizard, we do plan to expand on this. For example, we plan to allow you to rename the tables and the columns that you're pulling in, to map different tables to different destination schemas within the same pipeline, and so on. From here, I land on the pipeline monitoring page, where I can track the ingestion status of my Salesforce tables. These objects are shown in the DAG as streaming tables. Those streaming tables are going to process new data super efficiently as inserts and updates and deletes happen in the source. From here, I can set a schedule for how often I'd like my pipeline to run. In this case, I'll create a job that schedules my pipeline to run once every hour. And as a side note, we do plan to support continuous ingestion for some data sources like databases, where you have those near real-time CDC requirements. but we are subject to third-party API limits, so we can't offer near real-time ingestion for SaaS sources at this time. Finally, I can enable notifications to let me know when the ingestion pipeline starts running, when it's completed successfully, or whether it has a failure. Behind the scenes of that demo, we are leveraging a lot of powerful products that actually already exist in Databricks. It goes back to that point about unification with your existing tooling. For example, we use Unity catalog connections to securely store your credentials. That also makes it really easy to govern exactly who's able to create and edit your pipelines. Meanwhile, the ingestion pipeline helps you ingest incremental data quickly and efficiently. And finally, workflows allow you to schedule your pipelines plus any downstream tasks. Now, you might wonder how we actually establish that connection to your source. And for most SaaS instances, networking is pretty simple. Our job collects your credentials, and then it reaches out to what is typically a publicly accessible data source like an API. For cloud databases, we can connect via private link, or if the workspace has a peered VNet or VPC, we can deploy the gateway inside of it. For on-prem databases, we're currently testing connections through services like ExpressRoute or Direct Connect, but over time, we'll also explore an agent in a container that you can deploy on-prem. Now, that's the happy path. Let's quickly talk about what happens when things go wrong. For SaaS connectors, we have automated retries, and if that doesn't work, we'll pick up on the next run of the pipeline with the same cursor. For database connectors, if we see a temporary failure, the control plane will restart the extraction gateway as a first step. However, it's possible that we might see a persistent failure that does need user intervention, such as a backwards incompatible schema change. When problems like this happen, we provide alerting and error logging to support you. In fact, even though this is a managed product, we support the standard pipeline event logs, you can dig into cluster logs, and so on. We've actually added to pipeline monitoring. We've built a lot of new error messages, and we're adding new metrics. And that wraps up our chat about connectors. If there is one thing to take away, it's that we're offering simple, unified, and efficient connectors that are intended for any data practitioner. If you want to test the connectors out, or you want to influence which connectors come next, please reach out to your account team. We're also gearing up to ungate some of the connectors, so stay tuned for that. And finally, you can also check out our product page. Thank you for taking the time on connectors, and with that, I'm going to pass it back to Matt.
Thank you, Elise. And there's obviously lots of exciting work happening in this area in the Lakeflow realm, but there's also so much recent innovation that you can take advantage of today with ETL and data pipelines on Databricks. So to double click into intelligent data pipelines, I'm going to hand things over to Manish Dalwadi.
Thanks, Matt. So in this section, we're going to talk about how you can transform data and orchestrate those data pipelines within Databricks. So when you think about data engineering, like the thing that you really want to focus on is your code, writing the code, and then it just transforms the data into what you want it to be. But when you start to think about actually deploying data engineering to pipelines, it's actually kind of challenging. So think about like when you're ingesting data, and then suddenly those sources that you're ingesting, the schemas change. Or you get to the point where the scale of your data gets so large that just dropping the table and reloading everything becomes time consuming or just cost prohibitive. And then when you start to think about things like, oh, well, data is changing and I want to keep track of how the data is changing over time, like through like slowly changing dimensions or SCD2. This is a whole bunch of extra code that you have to build. And then when you start to add different pieces of governance and quality checks or versioning control and deployment of infrastructure to run it, it starts to get very complicated. And then it even gets even worse when you start to think about, well, okay, now I need to do streaming or I need to do data science. And suddenly you have a whole nother set of tools that are coming into your tool chain. And so what ends up happening is you end up spending a whole bunch of time not on that center box, but on the things outside that box. Our goal with data engineering on Databricks is we want you to spend most of your time on what really matters, which is your code and the business logic that you're building. So Michael talked about our vision for Lakeflow and where we're going. In this talk, I'm going to talk about two products that we have that are available today, Delta Live Tables and Workflows. These are products that you can use today. And our vision with this is as these products will evolve into Lakeflow. So you don't have to be worried about any type of migration as we move towards the Lakeflow world. So all of the good things that you see in Delta Live Tables and Workflows will be available to you. So data engineering, we've built this on top of the Databricks data intelligence platform. And what that means is basically you no longer have to have that data swamp where you have copies of data, different, same user has different IAM permissions and user roles spread all across different tools. The idea is that you have a unified set of data and a unified set of governance that works across all your analytic needs. So you can imagine creating a data engineering pipeline to ingest data and do some transformations. That same data and the same ACLs and governance can be used with your data warehouse with like DB-SQL. So this really removes a whole bunch of complexity when it comes to trying to do multiple use cases when working with your data. And today what you can see here is that thousands of customers use Databricks and trust Databricks for their data pipelines. You can see across lots and lots of industries, customers are using Databricks for large portions of their data engineering workloads. And the industry analysts are also seeing this. When you look at just the lakehouse in general, Databricks is the leader in this space. But as you kind of corner in and look at data engineering from like cloud data pipelines and stream processing, you can see Databricks is right there as well as a leader. This is one of the core strengths of the Databricks platform, is enabling data engineering use cases, whether it's simple batch all the way to streaming. So how do we think about data engineering within Databricks? We think about it sort of as an end-to-end flow, starting with data ingestion, then data transformation and orchestration. And then we think of use cases across it, like real-time processing or batch. And we know that like the fact that we have all these capabilities within Databricks doesn't mean that you may not want to bring your own tools to Databricks. And so we work really hard with our partners to support integrations across all of the sort of major areas, from data prep and transformation to data ingestion. So you can pick the tools that you want and make it work within Databricks. One of the big things that we've been focused on within data engineering is the move to serverless compute. And the idea with serverless compute is that you don't have to worry about the underlying infrastructure, and that Databricks handles the actual compute and the allocation, the spinning up and down allocation of a whole new thing on the fly for you. And what makes this really nice is that it's a no knobs thing, right? So you deploy your data engineering workloads. And Databricks will decide when to provision the hardware, when to scale it, and when to shrink it. What it means is that it's simple and fast. It's efficient because it's auto-scaling to your needs. And it's reliable, so that if something happens to the underlying compute that's running your pipelines, we'll detect it and we'll fix it. We'll put compute in that's healthy for you. Elise talked about ingestion, so I won't spend too much time here. But the idea here is you can ingest data from any source into Databricks, whether it's through our native connectors with like Flow Connect, or through our partners, or through custom libraries that you might be building yourself. Effectively, all sources are available to pull into Databricks, whether you want to do batch or streaming. So the next piece, we talked about ingestion. The next piece is transformation. And this is a special area within our data engineering experience. And what we do is we push towards this idea of declarative pipelines. And this is our Delta Lives table product. So with traditional data engineering, you describe how you want the data processing or data changes to happen. So you'll say, change this, then do this, then do this. With declarative pipelines, the idea is you just tell Delta Live tables how you want the data to look, like what exactly is the layout that you want. Delta Live tables figures out how to transform that data in an efficient way for you automatically. So this removes a whole bunch of that undifferentiated heavy lifting that we were talking about earlier on in the presentation. And so here are some things that it can do for you. So you describe like, I want the data to look like this. Delta Live tables will figure out how to process that data in a way that only the things that actually have to be changed get processed. So that means that your pipelines will run faster and cheaper. You don't have to allocate as much compute to go do sort of a full refresh of all your data. You can also define quality checks or expectations within Delta Live tables. And what that means is as data is flowing through your pipelines, Delta Live Tables will automatically check the quality of the data and actually quarantine or move data in and out and alert you as things are going. This means you have more reliable data. And the last thing, which I think is really special, is the unification of batch and streaming. The idea here is you can choose whether you want to trade off on latency or cost. And so if you need a low latency type use case, you can go towards like a continuous mode where Delta Live Tables is just processing the data on the fly, or you can push it to a batch model where you're updating it within every 24 hours. What's neat about it is that since it's a unified API, you don't actually have to change your code. A lot of times, if you wanted to go between batch and streaming, you'd actually have to use completely different tool chains. So Delta Live Tables consists of two core components. The first is streaming tables for ingestion and materialized views for transformation. With streaming tables, here's an example of a streaming table that's being created, and it's loading from a cloud folder that's called data. And what this does is Delta Live Tables will automatically pull the data. It will see what has already been loaded and what hasn't, so you don't have to reload data. And it also integrates with cloud providers like notification APIs. So this allows streaming tables to go to very, very large scale of ingestion. So you can have thousands of files coming in, and it will just scale. Another interesting thing around streaming tables is the idea of change data capture. So a lot of databases have these change data capture streams that you can capture from, say, a Postgres or a MySQL. With streaming tables, we have a verb called apply changes into. And what that does is it's able to look at all of the changes that happen in the change data capture stream and actually merge that into a DLT table efficiently. And what's neat about it is it will only do the things that actually changed for you. And it can do things like SCD2. So as data is coming in, it can actually track what's changed. So you know over time that this column, during this period of time, the value was X, and during this latter period of time, the value is Y. It does this all automatically with just with an API flag. So the second piece of DLT is materialized views, and this is for transforming data. In this example, you can see that a silver table is being created and with an aggregate around distinct products. The idea with materialized views is it's always going to give you the correct values based on the source and query. So what's really special about materialized views is it leverages a feature that we call enzyme behind the scenes. And so you could imagine like when some data changes, suddenly the entire materialized view has to reload the data, query the whole data again and reload it. It can be really expensive depending on like the types of change patterns you have. Enzyme will actually look at the changes that are happening, and it will look to figure out what's the best way to actually update the data. And so it can actually incrementally refresh the materialized view and avoid these sort of costly, time-consuming full recomputes. So when you put streaming tables and materialized views together, that's when you get a pipeline within Delta Live Tables. And when you do that, Delta Live Tables will actually look at your definitions for streaming tables and materialized views, and it will automatically figure out the relationships between the tables you defined and create a DAG. It will execute in an isolated environment. And if things go wrong, DLT will see that there's something wrong with the pipeline. It will do retries, it will do upgrades for you, and it will even do optimizations on what types of data it should be updating. So let's do a very simple example. So here's an example of an enriched order pipeline where we're creating a materialized view that enriches some orders and then has two downstream tables for BI use cases. So you just start, in Databricks, you just start in a notebook, and then you put in your three different tables, right? So the first one is that enriched orders, that's your silver level. And then the next two cells are the gold tables, which are doing like this, the middle one is doing a total price by nation aggregation. Then you just click start, and DLT figures out the rest for you. It figures out the dependencies between these tables. It realizes that enriched orders is upstream of the other two tables. It links it together. It will execute them in the proper order. If things can be parallelized, it will do so. And it does this all automatically for you. And then now you have a pipeline that's running, and you can just schedule it, or you can set it to continuous if you want it to run all the time. So I talked a little bit about data quality, and I want to dive into this one a little bit more. So when you look at Delta Live tables, there's a feature called expectations. The idea here is you define expectations within your table. So in the SQL example there's a constraint being applied on the timestamp. So the timestamps need to be greater than a certain date. As data starts flowing within DLT, it will actually check each record as it comes, and you can then make decisions like I want to retain the invalid record, I want to drop it, or I want to just fail the entire pipeline. All of this will get logged on the fly, and you can then see within the data quality UI for DLT what's actually happening, so you can actually see what the quality of your data as it's coming in. The other thing, I did talk a little bit about this earlier, but this unification of batch and streaming APIs, this allows you to really just decide whether you're optimizing for latency or cost. With a push of a button, you can go from continuous mode, which is optimizing for latency, to just to like a batch schedule of like 24 hours, which is optimizing for cost. The neat thing here is you don't have to make changes to your code. This is a unified API, and so you can kind of flip between the two depending on your needs. And some customers may choose to flip to streaming for certain periods of time and then switch back for other parts of the day. The other piece here is sort of monitoring your pipelines. DLT has a feature called the event log, and it offers a way for you to integrate with your other tools that you might have, in addition to just having native monitoring within Databricks. So you can use event hooks to actually send data to our partner integrations like Datadog or Grafana. You can do SQL alerts to send emails out to different locations. And then the event log is effectively a table that you can query, so you can build UI dashboards on top of it. So you could use AIBI, Tableau, any sort of dashboarding tool you can build right on top of the event log to create your own dashboards on top of the event log. So Trek is a customer that in the past had very complicated ETL processes they would take some raw data to get to parsed. And so they came to us and said that it was really challenging to sort of coordinate all of these things and have visibility on how these pieces come together. With DLT, they were able to achieve their use cases with a single notebook. So just streaming tables and MVs, and then using the monitoring pieces of DLT to see what's actually happening. Okay, so we talked about ingestion, transformation. So the last piece here is orchestration. Orchestration in Databricks is done through Databricks workflows. The idea with Databricks workflows is it's built to be a place where any data practitioner can create workflows. In addition to that, it provides a broad set of observability. So going from the top level of like I have 100 different workflows running, what's happening, all the way down to the very deep details of a single workflow and a single task within a workflow, what's actually happening, how long it's taking. You get that end-to-end observability from that 30,000 foot all the way to that 1 foot view. And the last thing is this is a product that we've been running for many years now, and so it is highly reliable at scale. It provides 99.95% availability. So when we talk about simple authoring for all data practitioners, you can see on the left side there's a UI where you can just point and click and create your flows. And so you can do control flows, you can do ingestion pieces, you can call tasks out all through the UI. In addition, there's IDE integrations. So you can write your code in your favorite IDE and then deploy it as a Databricks workflow directly from your IDE. The second piece is monitoring. And so this is sort of that 30,000 foot all the way to 1 foot type of view. So on the left, you can see these are all workflows that have been running, and you can see you get a full view of what's actually running, what's failing. You can quickly see what's actually happening across your entire set of pipelines. You can then jump into a specific pipeline and see over time what's been actually happening. So you get another degree of detail. But you can even go even farther. You can actually get down to the actual execution of a task to see where is it actually taking time. So like here's a ingest pipeline task that took about 7 minutes. You can see where the different pieces of time is actually being spent step by step. And reliability, as I said earlier, this Databricks workflows has been around for quite some time, and it's trusted by thousands of customers running millions of production workloads. This product is ready to deploy your data pipelines in a way where you know you're getting a production promise. And I think the last thing I want to talk about with workflows is sort of the maturity of the product. When you look at the different capabilities that it has, so if you think about triggers, you can go from manual triggers all the way to table triggers or continuous mode. With control flow, you could start with basic sequential type of control flows, but you can then go to like conditional ifs as well as for each. And then the things you can actually orchestrate, from notebooks to dashboards to dbt tasks to Python wheels, you get a breadth of capabilities with Databricks workflows that you should be able to orchestrate any of the workloads that you're trying to do. And here's a customer that is talking about the challenges that they've had in the past with monitoring. Historically, for this customer, they had multiple tools to do their data engineering. And as a result, getting a clear view of how things were working was very difficult for them. With workflows, they're able to put all of the data engineering, including Delta Live Table data flow type transformations, in a single place. And they're able to look at that high level view from 30,000 feet all the way to that 1 foot view in one place. That's all I have today. Matt, I'm handing it back to you. Thanks.
Thank you, Manish. So we've covered the three main ingredients of data engineering: ingestion, transformation, and orchestration. Now it's time to combine them into an end-to-end demo showcasing the magic of data intelligence. And there's no one better suited to deliver that demo than Frank Munz. Frank?
Thank you, Matt, for the introduction. You've seen many slides by now, so I'm excited to show you a hands-on data engineering demo that I built with the Databricks Data Intelligence platform. That demo includes everything you should have in your toolbox as a data engineer or as a data architect, including orchestration and data pipelines, how to integrate LLMs, which is the topic of the last 18 months, unified governance, serverless compute, and AI assistance, because, well, let's face it, we all sometimes appreciate a little bit of help. I brought you an application that is based on the cookies dataset, which became real famous at our Summit AI keynote. We used this dataset together with the streaming sales data to make real-time business decisions. In our case, we want to decide where to build the next flagship store for the Bakehouse Corporation. In the first part, I'm giving you a blueprint how to work with LLMs as a data engineer, showing you working code, and I think you should try this at home yourself. And then I also dive deep, obviously, into the relevant products and their settings and all the news that we have for these products. In the second part of the session, I will share the data set on Databricks Marketplace together with Databricks Asset Bundles that lets you deploy it, and I explain you how to do that. But first of all, I want to give you a quick overview of the workspace and the platform. What you see here is the Databricks workspace, and you see it's kind of divided into 3 or 4 different sections. And the first one is for SQL or data warehousing. And the second one, this is what we will focus on, is for data engineering. Then there is one for machine learning. And the important takeaway is all this goes back to the same data, to the same Delta uniform table format. So it could be Delta tables or it could be iceberg tables, and they're all based on, this high available cloud storage that comes with even better durability and this super low cost for cloud storage, like what you get in S3 or on the other clouds. And then we have Marketplace, and Marketplace will be very important for the second part of this presentation. And last but not least, we have Partner Connect that kind of gives you the window into this huge partner ecosystem that Databricks has. The Lakehouse is open. Many, many other vendors support it. The Bakehouse flagship application, it kind of serves two key objectives. First, we want a data-driven approach with live data to identify prime locations for new bakehouse flagship stores. And you already see the result here. These are the top 5 locations. And they're all derived by using live streaming data. And this is what we will cover in this first section. And then once we have those top 5 locations, we know the city, we know the local ingredients, we want to use a LLM to create a description of this new store. So if it's San Francisco and if the local ingredient is almonds, let's give us an idea of how this store could look like in this text-based format. So it's in Mission Street, a Mission District of San Francisco. It's using the abundant almond production, etc., etc. And both the locals and the tourists like it. And this is the data visualized in a AI BI dashboard. And that's the outcome that we want to achieve. And how do we get there? That's the question. And the answer is, well, the control flow, the outer loop, is a workflow. It's a Databricks workflow that implements like a couple of steps that are executed in this order. Like, first of all, we need to ingest the data. It's an ingest data pipeline. Then we have this if-then branch. We have a call out to DBRX in SQL. So we are calling the Databricks LLM to get this description. And then we update some downstream application because we have to. And if we don't want to use AI, there's sometimes local restrictions per company or per country. We can also just don't do that and branch here to this email exit without AI. So the first step here is this ingest pipeline. And if I look into this ingest pipeline, it's implemented with DLT, and it looks like this. First of all, we see there is more than one input source. There's actually raw suppliers, and these raw suppliers, they're provided by an XML list. And I'm going to show you this section, how to ingest the XML in a second. The other one is this raw sales transactions, which is coming via Lakeflow Connect from SQL Server. And then we have raw franchises, which is ingested also from Lakeflow, also via Lakeflow Connect from Salesforce. So we have 3 different ingest sources. We kind of merge the franchises and the sales data to derive the flagship locations. And the business rule is we only want to create a new flagship location where there is an existing franchise and where the sales is obviously the highest. So that's the business rule, the business objective. And then we need to consider these suppliers, and we need to find out what ingredients they supply. And last but not least, we will get to this top five number of locations where we will build the franchises that you've just seen in the dashboard. If you want to see the code for that, you can simply click here. All the pipeline is written in SQL. It's a DLT pipeline. That means it's declarative. We don't need to write, insert statements. We don't need to copy over the data. We just create this dependency, writing pure SQL. And for ingestion, we use the streaming table. So it's create streaming table. You see the raw franchise, you see the raw sales transactions, and you see these raw suppliers. So this is reading from a table. So the ingest part with the Lakeflow Connect already happened, and I'm just ingesting from that table. It's continuously updated, that table. So this is a streaming read, and it's therefore also streaming pipeline. It has a comment, and we basically ingest everything that we get in this table. Same is true for franchises. And then if you look at the suppliers, this is different. It's actually reading via cloud files, which is the autoloader, which is also a streaming data source from this location. It's a volume. That means it's a governed location, like a governed file system where we read in this file. And that's it. It's on another streaming table. And then we have this materialized view. As I told you, it's kind of joining 2 other tables to derive the locations where it makes most sense to build these flagship stores. And last but not least, we want to have another materialized view that we use as well, as a view, as a materialized view to create a dashboard. And this is what they're good for, like quick updates for dashboards, because those materialized views, they only recompute it if they have to, and they're kind of incrementally recomputed if you use serverless compute and if that's possible. If we go back to the graphical view again, and if you click on one of these tables, you also see the table name here, and that's the Unity catalog location. So it kind of directly takes us into the governance system. So if I have this raw supplier selected, I can see the sample data. I can obviously scroll through that data. I can click on lineage, and that's very interesting. I can see the whole lineage graph. And if I open this on every possible end and every possible side, you see, yeah, you see the whole graph here. And this is actually very exciting. This is more than just a pipeline. You can see that this streaming table is reading from a volume. That streaming table is reading from the other table that is kind of continuously updated by Lakeflow Connect. And the same is true here. Now it goes through from the volume, through the streaming table to the materialized view. And it's actually also kind of using another table. So it's table, pipeline, back to the volume. And now imagine if we had an AI model that we built ourselves, it would also show up here at the end. So you can really kind of find out what data is fed into your AI model. And you can explicitly also select who's able to access what. And we had the old days when, you had to allow everyone to access your data lake. This is not true for the lakehouse. In the lakehouse, we have these fine-grained permissions, and you can grant these permissions with the privileges to a person, to group, and so on. Since I have the notebook open with a DLT pipeline, I wanted to show you Databricks Assistant. That's what you get if you click on that little star, and you can use these / commands, such as /doc to document your code. Or another one is this /prettify command that improves the outline of your code. And again, you can accept or reject that code change. And something I find super useful is this /fix command. If there is like a bug in your code, it helps you detect and fix that bug. So Databricks Assistant, highly recommend to use it. And something else I want to point out, if you go to catalog and then we select one of the tables generated by the DLT pipeline, or it could actually be any table, and we go to sample data, there is this Ask Genie button, which is an AI-powered tool that helps us to generate BI queries by using natural language, like what I do here. And from the raw suppliers, I want to have an overview by continent. And it's just like spitting out the SQL. It's giving me the result table. And then, well, I can look at this and I can analyze it. It also shows me the SQL if I click on that Show Generated Code button. I'm not doing this here, but I click on Auto Visualize, and then you see it's even generating me a little dashboard, a graph that visualizes this table. And look at this. There's like lots of supply coming from Asia. Amazing tool. I love it. It turns us all into citizen data analysts. And now let's have a quick look into the AI callout. This is the SQL function that is actually using a SQL task, which is a file. And that file is here. In this SQL bit, what we do is we create a function that is generating the description of these new flagship locations. And as input parameters, we have like 1, 2, 3 for the location. And then we have the core ingredient, which could be the, pecans or oatmeal or whatever. And then it's calling out to DBRX, and it's sending DBRX the following prompt, which is a concatenation of, the instruction, like provide me a 3-sentence description of this flagship cookie bakehouse. You see, I even spelled it wrong. At the following location, I insert the parameters, and then I also insert the ingredient. And this function, that gen flagship description function, is used for a column in my flagship stores table. So I update a table, I set a description with the output of, calling that function with the other columns as a input parameter. And that's all. That's all I need to include LLM into your workflow. You basically include it in Databricks workflows as a SQL function, as a SQL query. Now, going back to a workflow that orchestrates all these tasks, I can add a new task by just clicking on this button, and it could be a notebook, it could be Python, or it could be one of these new for each loops. And all the compute is serverless. That's true for workflow. That's also true for DLT and for notebooks. That's the new default. We get the matrix view that shows past runs. It also shows you the total execution time at that first bar here. And you get the status of the tasks that were completed. So are they green? Are they red? Are they still running? This is when they're blinking. Now I select this one, which takes me to the timeline view that even breaks down individual queries that are run against the data warehouse. I see the query profile and I see time spent, rows, and peak memory. Okay, so after this walkthrough of the Bakehouse application, I think you all understand how we can gain valuable insights from streaming data and AI. You kind of hopefully understood how we orchestrate different steps, like having a data pipeline with streaming data and integrating a SQL callout to AI. And after exploring this application, now I want to dive deeper. We want to switch gears, and I want to show you how you can get to the exact same cookie data set using Databricks Marketplace. And I want to show you how to access a bundle of the Bakehouse application and deploy it with one command in your environment or in as many environments as you want, and how you can use Visual Studio Code to kind of code these Databricks asset bundles. So before we look into Marketplace, I want to show you my new workspace, which is actually the old workspace, but I cleaned it up. So there is no workflows anymore. There is no DLT pipeline. Under catalog, there is also no Bakehouse catalog. There is this Bakehouse active, which is empty. It's later used to generate the pipeline tables and the final result table. But this is like an empty workspace, as empty as it gets. And now what I do is I go to Marketplace. I'm using Marketplace from within my workspace, and all I do is just search for the cookie data set. And you can all do this right now. Don't do it right now. Listen to me first, but you can do it anytime at home. And then all you need to do is you click on Get Instance Access. It tells you it comes with 2 schemas, and I want to click here on More Options. Where do you plan to use the product? I want to use it on Databricks. And then actually that's very important, because otherwise you have to change the names. I need to confirm that I read that, and then I click on Get Instance Access, and this is all real time. And you know what? It already happened. So if I go to catalog now, you can see there is this Bakehouse catalog, and the Bakehouse catalog, it comes with the media schema that the AI people are using for customer reviews, and classifying those reviews and running sentiment analysis on top of that, and the sales schema that we want to use with the customer franchises, suppliers, and transaction tables. And it also comes with this supplier XML volume that we were using to ingest supplier data into this supplier table. So this is all like pre-set up for you. You don't need to use Lakeflow connectors to, for SQL Server and for Salesforce. All this was done previously. And then I took a snapshot as an easy starting point for you to play with this Bakehouse application. And that's the part from Marketplace. Okay, so to make those dApps work for yourself, to deploy this Databricks asset bundle for the Bakehouse application, just go to the tech marketing repo. We're going to share the GitHub URL later. What you do is you select the cookies data-eng dApp folder, and there you have the README for the main steps. This is not a getting started tutorial. This is just, to show you how this is working. And what you need to do is you need to have the command line installed. You need to get the cookies data set, and all this I've done already. And you have to have this other big house active catalog, and then you authenticate, and then basically you can just, deploy that bundle. Now, this bundle, once you check out the repo, is available. For example, you can open it with your VS Code. That's what I've done here. And I told you the bundle uses YAML files, or a YAML file, or core YAML file, which is this Databricks.YAML to describe the project and all the components in the project. And if you look at this, it kind of includes a resources directory with other YAML files. So any YAML file in that resources directory, which is actually this one, is also included. And then we define targets for development, and there is another target for production, and that's the workspace I'm using to deploy for production. That's the workspace I'm showing you all the time. And this is it. Let's look at the other two YAML files. That's the one for the data pipelines, and that's the one for workflows. And that one is actually pretty short because it references the code, which is stored here in this SQL file. That's the DLT pipeline code written in SQL, the one that we just looked at. And that one is a little bit longer because it contains all the steps for the orchestration. Now, if you're like me, you probably think like, wow, this is a lot to write. And like, basically this is like, if you wrote that manually, this is redoing all the same steps that you already did in the UI. And that's like not something very refreshing. And that's not something I'm drawing satisfaction from. So I recommend not to start from scratch and write this. So there's one way to do it. And I actually described this in the repo as well. And that's also what I did. And so what I did is I used bundle generate. And you can use the bundle generate command and give it a pipeline or a job argument, and then the ID of an existing pipeline or of an existing job. And guess what? It generates exactly those two files, like the ETL and the orchestration file. So this is relatively easy. And then you can still go and say, look, I want to parameterize this. I want to add a variable. And that's actually what I did for the data warehouse ID. And I did this because in this DAB, I'm not creating the data warehouse. I'm just referencing the data warehouse. And this is why I need to pass the ID. It has a default value. So in my command lines, you typically see me passing this value just to be on the right side, to make sure it's working. But you could also omit this if you set it here correctly. Now, the next question is, how do you run that? And the answer is there's actually two ways of doing that. So one is you just open a terminal. Let me try that. Yeah, this is my terminal. Let's just clear this to have a little bit more space. And then you run in the terminal. It could be an external. It could be like within VS Code. You run your deploy command, and the deploy command is that one. So I say bundle deploy, I give it the environment with -t prod, and then I specify my warehouse ID because I want to tell the bundle which warehouse to use to run the AI query. And this is for the profile. This is to get the right authentication. And let's try. This should deploy the bundle. And the bundle is getting uploaded to the workspace. It's deploying the resources, which is good. It's updating the state. And hooray, that's it. So it took us literally 2 seconds, like runtime, wall clock time, to deploy the whole application. Once you have the bundle, you can deploy within seconds. And that's what people do in their CI/CD pipelines. If they have like a Git action, if you commit something, it automatically kicks off this DAB deploy process. And guess what? There is also a destroy. I'm not doing it now, but just to show you, I could also say bundle destroy. That kind of destroys, removes the whole bundle. There's actually one command that I should tell you, and it's the validate one. So if I go and validate, it validates the correctness of the bundle. Let's see if this is true. Well, it should be correct because I just deployed it. The other way of working with Databricks asset bundles, which is even more tightly integrated with VS Code and kind of reduces the time you spend in the inner loop of development, is using the Databricks VS Code extension. We just published a blog posting about that. I recommend you go and read that and you check out the documentation. And then once you installed the DAB extension or the Databricks Visual Code extension, you can click on it and you see the configuration part. You see I'm deploying to prod, and my prod instance is under this host name. I still do actually development deployment for some reasons. And I am having a bundle with the workflows component, and you see this workflows component has these tasks, and I have a pipeline with these using that catalog and that target setting. And it even gives you the bundle variables that I defined. So what I could do, I could go here and say, well, force a deploy bundle or destroy the bundle or refresh the remote site. And well, this gives me a better graphical view of what's going on. So you can choose whatever you want. So I started with the terminal in VS Code, and now I'm switching more and more to using this Databricks extension. So if I go to my workspace that used to be empty, and I showed you that just to prove that I don't have any cards up my sleeve, and I click on workflows, wow, we see the workflow that was just deployed. And if I click on Delta Live tables, we also see the Delta Live table. And if I dig into that workflow, you see these are all the tasks, and that's the pipeline task, and that's the SQL query task. And it's referencing that file. And so what I do now is, well, I click on run. That's it. So I run the whole orchestration, which is then triggering, first of all, the ingestion pipeline, and then doing this if then else, and then doing the AI query, etc., etc. So now we're at this position, well, almost at the position from the beginning of this webinar where I showed you the full application. At the moment, there is no Bakehouse dashboard. And the reason for this is that the dashboards, the AI BI dashboards, are not included in DAB yet. Now, can I get to a dashboard? First of all, let's click on dashboards, and you see it's currently missing. But I can create a new dashboard, import it from a file, and then I select the file to import. Now, this takes a minute. Oh, wow, it's here already. I just wanted to say it takes a minute until the tables are generated from the pipeline. That actually means the pipeline was running already, and it did generate the tables. And now we can look at, like, what's the recommendation for the flagship store in Mission District in San Francisco. And, well, locals and tourists like it both. That sounds good. So the dashboard is working, which tells me the workflow was running. And if I click on the workflow, you see it ran and it succeeded completely. That's the branch I was not executing. And if I click on that run, again, you see it was perfectly doing whatever we expected it to do. So this is a success. It's as good as it could be. You know, we have the dashboard. We deployed the whole application. A single command. All we did is reference the data warehouse, which I could have omitted because it's a default parameter in the DAB. Now, as I told you, this is on GitHub, so you can easily download it, clone it, reproduce the example. It's a unique combination of, using Marketplace for a test data set that you can use forever what you want to do, and you can use the DAB to easily deploy this not complex, but rather complex application, doing everything from ETL to orchestration to AI query to dashboards. And that kind of brings me to the end of this session. Thank you for joining. And if you have any technical questions, please post them at community.databricks.com. See you next time.